Hey, everybody. Welcome back to Munro Live Podcast. And we're here today with John Stokes and Fiorenzo Dioni.
Yes.
Does that work? Because we can cut it out and do it again if you want. Is it okay?
Yeah.
Fiorenzo Dioni. Anyhow, and the reason that we've got two people on today is because Fiorenzo and Richard Obele just won a very prestigious award. They're the winners of the European Inventor Awards, and for their specific area of expertise, which is, of course, the high-pressure die casting. So I'm hoping that we can get a little bit of information on that from Fiorenzo. And if you could, can you give us a little detail on how you won that award and a little bit of background on how much of an impact it's having on the automotive? Actually, probably going to be more than the automotive world, because I think with the new aluminums that are being used, this would be great for aircraft and other industries. So, if you could, sir.
Yeah. Okay. The award is won because specific for the new injection system, but it is included in the global project named GigaPress. Okay. So, speaking about the GigaPress, generally it is a DCM, a die casting machine that is very big, okay, and starting from the very beginning, become the biggest die casting machine in the world, okay, and the dimension move from 6,000 tons to 9,000 tons, okay. That those numbers define the closing force of the machine, okay? Because the specific work of this machine is to fill liquid alloy in a die to create the solid part that the customer, who produce, needs. Above all, is dedicated to the production of the structural part of the cars, okay? And I want to highlight that actually the GigaPress are dedicated to the production of the structural parts of the electrical vehicle, but is not the only target of this kind of machine, okay? So, again, the first step is the biggest die casting machine in the world, and change the production of the structural part, because from steel part, 70 steel part that must be cutted, formed, let's say, assembly and weld, okay, in several phases. In one shot, you obtain the same part in aluminum. So it's lighter, the investment is lower, and above all, is dedicated to easy maintenance for the safety of the people, and this I include the patent that give us the European Inventor Award, okay? The new injection that is technically speaking, is above all dedicated to the energy saving. It means that is an injection system that regenerate the energy that's spent to move the piston to fill the aluminum. So the meaning is that instead to move fluid that we use for the different phases of the injection, okay, instead to move it in the discharge with all the consequences. So temperature, bubbleizing the fluid, and cavitation, possible cavitation, and so on. Simply, instead of move to the tank, we move directly to the source that give the movement. So it means that save technical parameters like pressure, velocity, and reduce the energy that needs to recharge the accumulator group that, again, move the injection. So is a project that contain the new DCM dimension of the machine and new system of injection. So many targets. Simplify the process for the customers, okay? Reduce the cost of investment, but at the end, even the cost of the cars, okay? And save energy, reducing even the possible damage on the operator that make maintenance. So it's been a project that keep many different aspects that are innovative, let's say.
I think everybody on the planet knows that IDRA produced these things for Tesla. Even Tesla has kind of admitted now that IDRA was their target. But I'm looking. You mentioned other potential customers and other potential industries. Can you elaborate a little bit on that? Can you say who you might be, what industries, anyways, you're targeting?
I think first of all, what we have to highlight is that this project is designed to make electric vehicles more accessible to the general population, right? We're in a situation where we're changing what we're doing in the world of automotive manufacturing, but the net goal remains the same, which is to reduce costs and to reduce energy usage. So having said that, you can imagine that most of the global legacy and new OEMs are directly interested in having a slice of the cake and getting involved with it. I think that it's really difficult to say who is directly involved and not. There are so many NDAs in place that it's really difficult to nominate anybody in particular. I think what we can say that within the automotive world, there is a general trend to move towards this. Now, that doesn't mean that this manufacturing process will replace all manufacturing processes. Stamping, steels, etc., still have a very prominent role within the industry. But it's true to say that the manufacturers are looking to reduce weight of the vehicle, reduce the lead time to manufacture for the vehicle, and that's super important. We used to have a turnover on vehicle design of every 5 years. Now, it's in some cases less than 2 years that the vehicle design changes. So we have to be able to respond quickly. That's the automotive world. For the other industries, obviously, logistics comes to mind immediately, right? The small delivery trucks, the standard sort of UPS or FedEx delivery vehicles are all transitioning to electrical hybrid. So they're also looking to get into this. But there's also other interesting stuff. There's things like aeronautics. There are also the applications for shipping as well. One of the big areas that's really interesting is to reduce pollution and reduce emissions from container ships, from shipping lines, etc. So, and we're even looking into other logistics-based projects that we can't really go into detail. But essentially, we've woken the imagination of the designers. Can we say it that way? And so people are coming up with, in some cases, weird and wonderful ideas that maybe won't go to fruition. But there's a lot of other guys that are taking this very seriously, trying to do something different.
We've been stuck in a rut for a long, long time, since the 50s or maybe even back to the 40s. And this, to me, is one of the great big giant enablers that allows us to think differently and make, I mean, everybody that comes to Munro sooner or later starts talking about how do we get into castings? How do we change what we've got to what we need to have? And unfortunately, there's quite a bit of what I would classify as, bad information out there. And that's one of the reasons that I really am happy to have you guys on again, to maybe clear up some of the misnomers and whatnot. So, but before we get into diving into some more of that detail, I was wondering if maybe the two of you could give me a little background. We have a lot of folks that are interested in finding out how or why or the path that some successful folks took in order to get to where they got to. So I'd like to see if there's maybe John, you could start it off. How did you get from where you were to where you are? A little history there. Yeah.
Right. Okay. Well, I have to say that from my own personal point of view, I come from a family of engineers, right? So I'd always considered myself somebody that would eventually get into engineering. My primary target when I was at school and then as I started university was actually to get into airframes and to play with aircraft. I realized early on that I wasn't smart enough, tall enough, or athletic enough to be a pilot, a fighter pilot. So decided that if I can't fly the things, I'll take them to pieces, right? It could be fun. And what happened was I decided to go to university and study mechanical engineering, and ended up on a mechanical and production engineering course. And quite frankly, it was accidental that I ended up in die casting. The course tutor came into the classroom and said, "Who would like to go for an interview?" And I went, "Yeah." And that was a die casting company. So really started at the ground up. Unfortunately for die casting, there's really not much practical schooling out there. Here in Italy, they tried to advance it a little bit. And in the US, NADCA, the North American Die Casting Association, has been very instrumental in promoting die casting to mechanical engineering students. As you can imagine, the world of die casting is a little bit niche, to say the least. And most of the students tend to head towards plastics before they go towards this stinky, nasty aluminium. So,
Stinky, nasty.
from my point of view, the foundry world is a super interesting area. It is an area in which, for me personally, as an engineer, as a mechanical engineer, I've had the possibility to work on not only mechanical solutions, but hydraulics, pneumatics, robotics, electronics. We've had to learn really as we've developed through the program. And bear in mind, I've been working in the industry now for almost 40 years. I've been in IDRA since 1995. So it's really been a case of working from the ground up and putting the practical work in. But of course, the university education has been important and has enabled me to have a more wider view of what's going on out there in the world. I'm aware of different manufacturing techniques and try to keep myself up to date of understanding where the possibilities are lying. I mean, as you know, Sandy, there was a big drive some years ago to go towards carbon reinforced plastics, right?
Yeah.
It became apparent very early on that whilst that gave the best results for vehicle lightning, it gave us huge problems for the recyclability, for the eventual chain of returning of material to reutilize it. And for me, that's something that aluminium has always been fascinating. It is an everlasting recyclable resource at one level or another. I can basically take a frying pan and convert it into a door handle. That's really not a problem. So from that point of view, I think that what we're doing is super interesting. My background started off as a mechanical hydraulic technician. and developed into more of a commercial style role and got more involved with marketing and more involved with the driving the business forwards and directly trying to work together with Fiore and the team to come up with ideas as well that would drive the GigaPress project forwards. Because I think one of the difficulties for us was absolutely convincing the traditional OEM manufacturers to actually look at this seriously and consider it. And it has to be said that thanks to one particular company, who from our side we can't nominate at the moment, but from one particular company, having the drive, the ambition, and the disruptive thinking to actually make a change. And so that's really where my background has been. Fiore, you're coming from a slightly different direction.
Yes. No, it's just a little bit different, my background, because I have the high school diploma, because when I was young, I lost my father when I was 10 years of age, and my mother in that precise moment was in layoff, and so I have to invent myself in order to have some bucks in the with me, and I start to work very young, and I complete the high school, and how is in English, scuole serali? Evening school.
Evening school.
Evening
Yes.
school.
Yes.
Okay. But I found, because at that time was not so difficult, I found a job, okay, on the tool machine for 5 years. And then starting from 1984, I moved to the engineering department in injection molding machine company. And I designed and project injection molding machine until 1998. And then moved to the die casting and remain in die casting. So the meaning is, I'm in this field starting from 1984, okay? And because I want to know, okay, I have to highlight anyway that university is really important, okay? But I've been not so lucky, and so this improved my curiosity, and I work very close to very expert men that I call them my masters, and I learn many things, and because of I was very interested in becoming an engineer to project the machine and so on, and so my experience move until now, and but I have been very lucky, because in IDRA, I already have the possibility to suggest my ideas and to develop my ideas without some obstacles, speaking about the money to invest or restriction from the management and so on. And so I suggest many things. For example, even the closing group of our machines, okay, we had at the beginning the patent of the closing, toggle-free closing. Okay, now we use the system called toggle system. Our competitor use toggle-free, but who patented the toggle-free has been IDRA. And then we choose to move to keep the closing in with the toggle system, to move our let's say impegno attitude to the injection, because it is the real heart of the machine. Above all, now that the machine become bigger, starting from the 4,200 tons, 550, 5,500, 6,000, 9,000, so on. The most important thing to develop has been the injection, because moving to fill 30, 40 kilos of aluminum to 150 kilos of aluminum is very different. And so remain that let's say, is not, I'm not arrogant, but I create myself because in a different way, I had nothing in the past. and so I grew my curiosity. And again, I've been lucky because I met this possibility and very good guys that teach me on how to grow up.
I've met quite a number of people who've made it, but they made it without a degree. So I think that you're an inspiration to other people. Everybody says, well, if you don't have a degree, you don't have anything. Well, at the end of the day, there's a lot of people that I bumped into that don't have a degree and are changing the world. So that was a surprise. I'm happy to hear that you are a self-made man, and I applaud the fact that you're now a dignitary in the world of invention. So there you are. That's the way I see it. Yeah. Yeah.
He's an award-winning engineer now, right?
Yeah,
So,
exactly. You'll have to call him Mr. from now on. Yeah. Yeah.
To be honest, anyway, I choose to work, find a job, even because I want to buy a bike. Okay. Unfortunately, I bought the bike without tell to my mother. Okay. But after 1 week, I break the bike. And so my mother broke me.
It's the wooden spoon teaching.
First step has been
Yeah.
that.
Yeah, I got through high school and I was a tool maker. Again, you were mentioned that you worked in a tool shop as well. I was a tool maker, and then I went back to college, and I hated school, so things didn't work out. But I will tell you that as soon as I had enough money, I bought a motorcycle. Much to the chagrin of my parents. My dad said, "That's a death box." My mother just cried. So there you are. You can't trust a kid who's only 18 years old at all. Yeah.
my father, in fact, took my motorbike off me and gave me a windsurfer and said, if you fall off that, it's water. So,
Okay.
Well, there you go. We were a little on the poor side, so we didn't have a car at all. And my dad didn't drive. During the war, he was blown up a couple of times, and he lost one eye, and he didn't feel comfortable. And my mother, she was old-fashioned, and she thought that women shouldn't drive. They both drove. My dad learned how to drive when he was 55, and my mom learned how to drive when she was about 56 or 57. I can't remember. But it's amazing how over the years people say, oh, well, you can't teach an old dog new tricks, and there you go. There's a couple of old dogs here, and we're teaching everybody new tricks. So there you are. So I've got a question for you. We've heard a little bit about the Foundry Star Alliance, and you guys are in it or started it or something. Can you give us a little detail on that?
we are a European consortium of the lead manufacturers within the die casting industry. And when we first started down this route of thinking about doing a supersized die casting machine, one of the difficulties for us was to understand how we could not only produce the press, but ultimately how we were going to handle and finish the component that we wanted to produce, because this is a big chunk of aluminum coming out the machine. And we have to be able to prepare the mold, we have to be able to follow the process, and we have to be able to extract and finish the component. So in order to do this, either you try and become expert at everything yourself, which in our experience never works, or you get together with the smartest brains in the industry and figure it out. So the Foundry Star Alliance was really a practical solution to a problem. The problem was that Fiorenzo came up with the idea of the machine and how we're going to do it. We already had an idea of what it meant to die cast, but in order to do so, we had to invent some new equipment on the machine to follow this. So what we did was we went out into the field, we spoke with our partner companies here in Europe, and we put together a team that would be a team designed to solve problems. And that's essentially what the Foundry Star Alliance is. And we're quite proud to say that we've been able to keep a collection of 5 different nations through Europe, even though we just had the European football tournament, still talking to each other and trying to find solutions for the result. I have to say, at this moment in time, Spain is not inside the FSA, but they weren't beforehand, so we didn't throw them out, right? As an Englishman.
Yeah. Well, there you go. Yeah. Well, I was wondering, can you name the other members of the alliance?
Sure, we can, for sure. So I try and make sure that I get everybody. So first of all, we have our tooling partner, which is a company called CoStamp, and they are an Italian-based tool manufacturer. And they were one of the first mold manufacturers to actually produce giga tooling and to go into the field and make it work. So some of the vehicles that you guys are out there driving right now already have castings made off their tooling, right? So that's a company called CoStamp. Then regarding the spraying technology on the tool, because we have to put on a release agent onto the tool, we're using a company called Volin, and they are based out of southern Germany. They're just outside Stuttgart, and they're one of the leading manufacturers of spray equipment. And their task was pretty heavy. They had to come up with a solution that would allow us to achieve very short cycle times on the machine. We have to get in there, spray the tool, and get out, so that then we can close the die casting machine. So yeah, they put a lot of contribution in. In order for us to fill the tool, we need to use a vacuum assist. And so we've partnered up with a company called Foundry that are based out of Switzerland. And they've been for many years one of the leading protagonists towards using vacuum in die casting applications. And pretty much are well known all over the world. So then we also have to consider how we're going to keep the tool temperature controlled. And so for that, we've turned to a local company here in Brescia. They're literally 10 minutes down the road from us. It's a company called IDRA, and they produce what we call thermoregulating units. That's basically we're pumping hot water or hot oil around the mold. And even though the water or the oil is hot, compared to the aluminum, it's cold. So this is providing a heat exchange media that allows us to take out some of the latent heat from the tooling and allows us to have the rapid cooling that we require for the casting process. Then from there, I guess we should touch next on to the furnaces. Obviously, the preparation of the molten aluminium is super important, and we have to deliver the aluminum or the aluminium into the die casting machine in a fast way. One of the difficulties is that when we're dealing with up to maybe 200 kilos of aluminum, we have to be able to get it inside the machine as quick as we can. It's cooling all the time. So the delivery systems are super important. And we've worked very closely with this company called Stokes, and they're based out of Denmark. Then beyond that, we then have to consider what we're going to do for finishing the casting. And so we have another Italian company called Meccanica Pieri, with whom we cooperate to find solutions for removing the, how can we determine this? As we cast the product, there is some excess material that forms around the product that we call overflows or runner systems. We have to remove those parts once we finish casting. So they are primarily involved in finding solutions for, we call this degating. And so they have been involved in finding solutions for not only mechanical press, but also for laser cutting and plasma cutting for removing the excess aluminum in a quick way. And then one other company that I think often gets overlooked is a company called KMA. That's a German-based company. And their job is to filter the whole atmosphere around the machine. So obviously, one of the problems we have these days is that we have to keep an eye on whatever we're doing, not only for the environment outside the building, but the environment inside the building for the operators. And Sandy, you can maybe appreciate that this is a new process that we're now looking at, no longer in a dirty traditional foundry, but now in a body in white application at the end of the assembly line of a vehicle, or the beginning. So at the beginning of the assembly line, we now have these large gigapresses, and they're running cycle times that vary from anywhere between 95 to 120 second cycle times. And if you then multiply this over the number of machines, which is normally around 6 machines that we require to produce the necessary quantity of components for mass production, then you're producing quite a bit of potential contamination from the release agent and from the steam that comes off the mold into the environment where we're trying to work and build cars. So basically, KMA supplies for us and has developed a series of new electrostatic filtration systems that helps to keep the environment within the building, but also maintain any fumes that are going outside of the building so that they're clean, and we're able to keep this process into a healthy environment, both in and outside of the building. I think I've got everybody there, right?
Well, you mentioned one thing that I'm very interested in. In fact, I've been asked a bunch of questions on this, and truly, I did not have what I would classify as an accurate number. But people have asked me, what are the segments to the cycle time? Like, how long does it take to deliver from the furnace to the chamber that you're going to be shoving? How long is the cycle for actually filling the mold? How long does it have to sit in the mold? How long does it have, or how much time does it take to degate and then ultimately get out of the area? Now, you mentioned about 120 seconds, 2 minutes. That's the biggest number I've heard so far. So could you give us a kind of a ballpark for those different steps?
First of all, we have to divide what we consider to be the actual casting process against what is the secondary processes on the component. So obviously, after we've cast it, we have to remove it, we have to handle it, maybe we have to do some laser marking, plasma cutting, this kind of stuff. And so when I'm talking about 90 or 120 seconds of cycle time, it's including everything. And we call this shot to shot, meaning from when we fire the injection to the next cycle that we fire the injection, we have to go through a series of processes. However, the actual casting process itself takes less than 15 seconds. So the filling of the mold is around about 120 milliseconds of actual metal entering into the mold. But before we do that, we have to pour the aluminum into the pouring sleeve. And then we have to move it forwards before it's ready to actually, and expel all of the air before it's actually ready to fill the mold. So I think a lot of people get confused about that, Sandy. A lot of people think that the casting process is the only part. It's just a small part. Once the aluminum is inside the mold, we then have to cool the aluminum. We then have to open the machine. And so what we have to do is consider all of these steps. So a big part of what Fiorenzo has been doing is to optimize the equipment so that it can operate in the fastest cycle time. And of course, we have very strong targets right now to operate at less than 60 seconds as a complete cycle time from shot to shot. But at the moment, it's also a case of, can all of the other equipment that we mentioned before with the Foundry Star Alliance, Can all of that equipment stay behind a cycle that's moving that quickly? So I don't know, Fiore, would you like to explain a little bit the die casting process going from the pouring of aluminum through to the extract?
The process is, okay, starting from the open machine, okay? So the first phase is close the machine. So put in contact the two half dies, okay? And so in order to create the print to fill with aluminum, okay? And must be close at the force that avoid that the reaction of the aluminum of the alloy open it, okay? Then you have to fill, as John told before, okay? You have to fill the sleeve, the shot sleeve, okay? And then you move the piston slowly in order to avoid the air stay inside, avoid to put the aluminum outside because of the eventual waves and so on. And that is, in our solution, that is exactly the phase that you regenerate the energy in the injection, okay? Then when you arrive at the end of this slow phase, okay, you move very, very fast in the last stroke, okay? The piston, so means the injection, to fill the die quickly, okay? Then when you fill the die very quickly, you have to keep the aluminum there and avoid that the piston return. And in that case, you have to intensify the force that you use to keep the aluminum there, okay? Because when you fill the die, you fill with a centering force, okay, on a square surface, create a pressure. That in that case is a back pressure that try to open the machine and put back the piston. So you intensify the force in that moment to avoid deformation, and above all, that the air remain in the cast part, okay? After that phase, you are stopped because you need to set the cooling time. There are two cooling times. The first one, keep the force of the closing and the force of the injection with the highest value, okay? After the first time, okay, you release the injection, but keep the cast part inside the die, okay, improving the cooling. At the end of this time, you open the machine, okay, with the injection, okay, move forward to, let's say, accompagnare, how is in English?
Follow through.
To follow through the part. When the machine is open, that means that you discharge the two half dies. In one of those two halves remain the cast part. After that phase that you arrive in the position of backward, the backward position of the closing, okay, there is a robot that go inside between the two halves, keep the part from the biscuit, that is the part that you fill the aluminum, that is a round part, okay, keep the cast part. Inside the moving part, the moving half of the die, there is a system that is named ejection unit, okay, that push the cast part. The robot already kept the part, moving this way and take out the part from the machine, okay? Then the machine restart, and so it means that you finish the cycle. But meanwhile, or better, while there are all these phases that I explain you, okay, take out the part, you check the part connected to the robot, okay, check the integrity of the part, Then depends of the component that the customer produce, okay? Or you cool immediately, then after the cooling in the water, okay, or through the air system, you take the part and move on under the trim press, okay? With the trim press, you cut and throw away, let's say, the gauges, okay, the channels that fill inside the die, the aluminum, okay? Then, depends on the cycle, you move the part to be marked by laser marking and so on, and then put on the nastro
Conveyor.
Then move out the part outside the cell. That is more or less the.
So again, we need to dispel this misunderstanding that there is. It is a super fast forming process. The actual forming process itself is similar to when you're doing stamping, deformation of metal, right? The closing action of the press deforms the metal. In our case, we're filling the mold with a molten or a liquid material, and the mold creates the shape.
Well, I know when I was at Tesla, I did not a scientific test, but I watched the machines running, and I only looked at from the time that the robot removed the existing shot, pulled it away, till the time that the next robot came in to pull it away. And that I got in at, one was at 48, one was at 52 seconds. Now, they weren't running at high speed either. I'm not sure exactly whether there was any chance for them to modify that cycle. But to me, I can't do that with a bunch of stamped parts that have to be welded together. And so I think that's why the guys at Tesla can get a 43-second cycle time, and I can't do that with I can't do that. Period.
Well, I have to just jump in here and say, first of all, due to the nature of the NDA and that, we can't confirm anything related to the actual processes within the Tesla group. But what we would like to do is to say to everybody that this is the big challenge that we have now. How do we optimize this equipment, get it to work harder, and get the assets to work better so that we can reduce not only the cycle time of the building of the vehicle, but also the number of machines that are required to do this. One of the difficulties clearly is that the size of the press and the amount of mega amps that we need to run these large presses is a situation that needs to be addressed very clearly. And it's something that we as a team, we're working on very hard right now to optimize the equipment that's out there. There's a lot of discussion right now, Sandy, about the possibility to manufacture a 20,000 ton machine or a 15,000 ton machine.
Really?
From our point of view, our goal right now has to be to offer a robust and sustainable manufacturing process. And that's really what we're very focused on right now. For sure, there are companies out there that are working on these larger presses. But until now, we see very clearly that the current applications that we're talking about, which is the battery trays, the underbody parts for the vehicles, and eventually some of the topside components as well. The automotive industry wants to optimize cycle time, and the original dream is still alive. Can we cast one entire vehicle in the shortest possible time? We're a long way away from that right now. But what we have done is that we've moved forwards into a situation where we can now offer the designers of vehicles And when I say vehicles, I'm not only referring to electric cars. We can be talking about e-bikes. We can be talking about motorbikes. We can be talking about trucks and boats and aircraft as well. All of the imagination of the designers has been stimulated. And I think that really this is a great credit to Fiorenzo and the team of engineers, that they've been able to change a mindset that has essentially been stuck for a good number of years, have things really changed so substantially from Henry Ford, right? And by the way, I remember that I was involved in a speech, Sandy, I think you were there with us at our forum, right? When one of the key speakers said that, remember that the automotive was brought about as a solution to horse pollution because there were so many horses polluting the water table that the automotive vehicle itself was a solution to sustainability. And we think this is still valid today. This is what we're trying to do now.
Well, at the end of the day, yes, that's one of the things that I discovered when I started doing research on why did things change, and quite frankly, they changed quite rapidly, and that's where I think we are right now. We're in a change mode that's going to be eclipsing what the predictions are. I've always had arguments with most of the guys that are analysts and whatnot telling me that can't happen and this can't happen. And we've had more than our fair share of bad press because, somebody says, oh, no, it's not going to happen until 2045. And like, these guys, I don't know where they're getting these numbers from, but they don't make sense when you talk about history. So if we look at where we are right now, with castings and stuff like that, I think that the world is going to be shocked in the next 5 or 10 years with what is going to happen in like I say, in probably less than 5 years. We're going to see a tremendous change. That change is going to be is going to leave a lot of industries behind. And unfortunately, right now, if they were listening more to maybe companies like IDRA, there'd be the change could happen faster, and there'd be less casualties probably at the end of the day. And that's kind of why I really wanted. That's why I promote you guys. The other one is just strictly money. Strictly money. I designed, I don't know, a dozen car plants. And when I came and gave my speech at your facility, or the big casting thing that you had, not last year, the year before, right?
Before, yeah.
Yeah. Mm-hmm. So when I came there, I brought my little study, and I know how many different pieces of equipment you need in order to make a stamped car. And when I put my thing up on the screen and showed all those blue holes, that's free space. When I got done, I even doubted my own numbers, and I cut it back. I said 30%, but I know it's closer to 40% of the floor space disappears. When you do this and you get rid of the whole front of the body and actually the whole underbody period, and you're only looking at the skin, the top hat, things change dramatically. Your floor space is like near gone. And quite frankly, I just came from our sales meeting, and somebody wants us to design a new plant for a new product, a new type of vehicle, and they're trying to determine how big the size is going to be. And I brought it up in the meeting today with my people. Tell them that we can do it the old-fashioned way, and you'll need, over 1 million square feet or something like that. Or we can change it around a little bit if they don't want to pour that much cement, and we can drop it down to about, let's say, 600,000 or 700,000 square feet. Well, you know what? That's a lot of concrete, and that's a lot of money just for the building. Just for the building. If you go to if you go to a casting solution. And who knows what, I didn't know, I don't know how to envision one casting to get a whole car, but at the end of the day, I used to be an advocate of casting, but I never would have guessed how quickly and how effectively and efficiently your machines can crank out the front and rear of a vehicle. So I'm a huge fan, and I don't know where you guys are going to go next. It's probably I'm not smart enough to try and guess that. But I can tell you one thing: the future is going to look a lot different than what the past has been, and I think that there's a huge future in the casting world, huge. So that's my comment anyway.
Well,
Feel the same.
clearly we are advocates of the use of aluminium in vehicles, but I think one of the final discussion points has to be the current situation in the automotive world is that a lot of politicians around the world force the agenda for us to all jump into fully electric cars. And one of the difficulties has been to have the infrastructure to support that, but also to have the vehicles to support that. So one of the big changes taking place right now is a half step backwards towards plug-in hybrid vehicles. And I think it's really important, Sandy, to get the message out from this podcast is that this process is not limited to electric vehicles. This process is equally applicable to a gas engine, or applicable to a hydrogen engine, or applicable to a hybrid, utilizing both systems. And one of the things that we're clearly seeing within the marketplace right now is this utilization of smart materials to get the job done.
And that's right.
That's what we're trying to do, right?
Because they define and study new components, they know that can we produce this part? Yes, we can, because the machines are already available, let's say. So they can invent a new solution for the cast part.
Yeah. Well, I'm hanging my hat on people with maybe a broader view on how things can be done. I hate going into like a conference to give a speech and whatnot, and there's some jamoke in the back who's totally invested in one way of getting the job done, or one material to get the job done, and I get this heckler and whatnot. And I try to be as civil as I can, but remember, I got out of college by belting a guy that heckled me. So at the end of the day, I've got to try and hold back, but I think there's the momentum that you guys have got things going. And there's quite a bit of momentum now in the area of carbon fiber, because now we know how to recycle this stuff. I mean, there's no question about it. This is, so for a top hat, I don't know how to do that with a casting, but a top hat with carbon fiber. Now I've got the light, if you like, a skateboard, they call it, and different people, rolling chassis. But I've got that lightened up with castings. Well, why do I need sheet metal? If I can, in fact, in Italy, there's a company called CPC, and I've never seen anything as brilliant as what those guys are doing with carbon fiber. So Italy, for me, seems to be kind of like the epicenter of new thinking. So that's what I think, anyways. So,
well, obviously, I'm an Englishman. As we like to say here, an extra comunitario, because we decided to leave the European Union. But I'm extremely proud to be an adopted Italian. And I think that from our point of view here, we are ideally placed within the European community to make best access. We've got great minds, we've got great thinkers here in Italy, and we're able to think outside the box but applying good, solid engineering processes. And at the end of the day, this is not a refrigerator that we're building. This is a substantial piece of capital equipment.
Yeah.
And I think both of us are really proud to say that we're an Italian company leading forwards into a new era of vehicle manufacturing.
And for that, you should be commended. In fact, you were commended. You got an award. So, yay, yeah.
Exactly the time that he became the boss.
And he had it all planned. I'm sure of it, right, John?
Yeah,
You're
right
sure?
from the get-go, yeah.
Okay, good. Well, anyways, I'd like to thank you both for coming on to our podcast here at Munro, and wish you all the best. I heard you're going to be doing some big-time traveling. Good luck with your travels, and try and stay cool. 38 is pretty damn hot. So, anyways, thank you again, gentlemen. Thank you.